In this video, I'm going to be talking about the program execution process, or how a program is actually converted from source code to binary. The steps that the program is going to go through, okay, when it's going from source code. Okay, so source code meaning when you write your Java, okay, from source code and then get into to zeros and ones. We're going to look at the stages, and we're going to study each and every stage, what happens at every point, okay, in the life cycle of a computer program. Okay, so you need to understand that first of all, the computer program, the first stage is where you have source code. Source code, this means the instructions that you write. Okay, here we have the code. Okay, the instructions that you write that the computer should do for you. So you can write this in C++, you can write this in Java, in any programming language that you want to write. So the instructions that you write here, this is the first stage, which is the source code. After you've written your source code, the second stage that will come is going to be called the software that runs. This is actually a software. So after that, the source code is going to be passed to a software called a preprocessor. Okay, so now in this second stage, why do you need a preprocessor? A preprocessor is necessary because a preprocessor is going to clean, okay? It prepares the program or the source code for compilation on the third stage. So here it's going to prepare the program for compilation. How does it do that? It's going to remove comments, it's going to remove white spaces, okay? At this point, you're going to have removal of all unwanted elements in the program. So removal of white space, it will remove comments, okay? That is what the preprocessor is going to do for you. After the preprocessor is done, to get the source code that it has prepared for compilation, you need to run it into the software called a compiler or an interpreter. So the interpreter here is not going to convert the source code into binary directly, no. What will happen is that here, you're going to have what you call mnemonics, okay? So the compiler is just going to change the source code that is in Java or in Python into assembly language. So assembly language uses the concept of what? The concept of mnemonics. So mnemonics sounds like a very big word. So what are mnemonics? Mnemonics are just simply keywords, okay? They are keywords that are assigned. Because assembly is actually a programming language. It has keywords. Because at the assembly level, here when the program is compiled into mnemonics, at this point now, the information or the instructions that you have programmed into your computer software is being packed into registers. Okay, so to do that, you need the use of what? Of assembly. Okay, so assembly uses what? Uses mnemonics. Okay, so after you now have this assembly language here, which could be assembly 8086 or assembly 8088, okay? So here what you have is assembly, okay? Assembly language. So it is no longer Java, it is no longer C++, it is no longer Python, but what we have at this point is what? What we have is called assembly language. So now your program is now converted, it has been translated, right, into a different language called assembly. Okay, I want you to keep this in mind. So assembly has keywords like move. Okay, so move, you have a hash here. We're going to say H or maybe O hash, E, B, okay, any type of register. There are so many types of registers. So maybe if you had said there's a 1 in your program, to say move 1 into this register, move 2 into this register, move this instruction to this different register. So information here is being packed into registers in assembly language. So now when you come to the assembler, at this fourth stage of program execution process, the assembler, what the assembler is going to do for you is that it is going to get the mnemonics, okay? It gets now the assembly language and then now converts it into binary. So binary conversion actually happens on the what? On the assembler software or at the assembler stage, because the assembler is a software that now gets these mnemonics and then converts them into what? Into binaries of ones and zeros. Okay, so now your program is finally in what? It's finally in binary. So it's not a compiler or an interpreter that converts the programming language actually into binary. It's an assembler that does that for you, or that does that job for us in the computer program. So a compiler and interpreter always be defined as a language translator that converts programming language into binary, but the binary conversion actually takes place on what? On the assembler here, assembler software. Then from the assembler, we're going to have what we call a linker. So what is a linker going to do for us? So the assembler is going to pass now the binary code, okay, of our computer program into the linker. So we are now reached here the linker. What is the linker going to do for us? So in your computer program, you're going to have the source code that you write for yourself as part of your application, right? Then there's some other source code that you're going to get from maybe GitHub or get from other people online, or maybe you built it a long time ago and you want to reuse it. Mostly called libraries, APIs, or frameworks, right? So this source code, this external source code that you get from outside and integrate into your own computer program here, this source code at this point is now added to your computer program. Okay, so it will also be added in binary here. So we have your own program, okay, your own program plus the source code from an external program that you hooked, or a library that you put into your application. Okay, so this is where libraries now are added. Static libraries, dynamic libraries, they're added at this stage on the linker. Okay, so now we have a huge chunk of binary. We already had binary here. We have more binary added from external libraries here. They're added from here. Okay, so after that happens now, this binary will be passed into the loader. What does the loader do for us? As the name suggests, the loader is going to get now all the binary code that is in the program. Is going to take it into memory, into a computer memory. Okay, it will take it into the RAM. Okay, the random access memory. So every program that is running on a machine is always running from what? Random access memory here. Okay, so now your binary code is running into the random access memory. Okay, it's pushed into the RAM. So from the RAM now, when the computer enters the RAM, now it enters the execution stage. So at this last stage here, the last clip here, it's actually execution in memory. So now your program is now in execution. So this is what happens. Let's say you are on the desktop of your computer and then you click the icon for Photoshop. When you click the icon for Photoshop, this is the stage that is going to happen. You're going to go from source code to pre-processing to compilation process. We're going to go through the assembler, you go through the linker, the loader, and then execution. Okay? So you need to understand that this period, when the program is running from the source code until it reaches here on the loader before it is in memory here, this process is what you call the compilation process. Okay? So when you say that a program is at compile time, it means it is running through these stages here. It is not yet in execution stage, because at execution stage, you as a user are now able to see. So when you click on the icon, it runs here. When you click on an icon and then nothing is showing on the screen, this is the process that is taking place until here. When the program officially opens on the screen and then you're able to use it, it is now in memory. So now when a computer program is in memory and it is running and the user is able to use it, at this stage, this is the stage that you call runtime. Okay? So we have runtime and we have compile time. Okay? You should know those two different things. So there is runtime here, there is compile time here, okay, when the instructions are being converted to binary, and then we have compile time here when instructions are being converted to binary, and then we have runtime when the instructions are now in RAM, they are running, the processor is now executing these instructions. Okay, so this is how program execution process happens. So every time you're compiling a program, when you're programming, this is what will be happening here. Okay, this is what will be happening. Okay, so this marks the end of program execution process.